Hey everyone, and welcome to Blumira Briefings, your weekly download of the top headlines and trends for your security practice. I'm Julie, in for Zoe, and this week we're looking at 4 stories that initially seem pretty different. One involves public-facing Salesforce and ServiceNow portals, one involves compromised cloud credentials, one involves infrastructure used to run AI, and one involves an AI agent escaping its own testing environment. But there is a common thread. In each case, the security boundary wasn't quite where people thought it was. Let's take a look. We usually think about a data breach as someone finding a vulnerability and stealing credentials or somehow getting around an organization's security controls. But what if the attacker doesn't have to break in? Researchers have been tracking a campaign called City Forum that has been targeting Salesforce Experience Cloud and ServiceNow customer portals. The interesting part is that researchers haven't found evidence that the attackers are exploiting a vulnerability in either platform. Instead, they're using something both platforms are designed to provide: anonymous or guest access. Organizations can configure these portals to allow unauthenticated visitors to search for and retrieve certain information. The problem is that some organizations have exposed considerably more information than they intended. The attackers are using automated requests to figure out what information is available and then retrieve it. The campaign has reportedly been operating from the same infrastructure since at least March 2025, and researchers have seen the activity targeting organizations across telecommunications, financial services, software, security, and public sector environments. So this isn't a smash and grab attack. It's much quieter. The attacker finds something that an organization has intentionally made accessible, figures out what else that access provides, and then systemically collects it. So if an attacker doesn't need to bypass authentication to start collecting information, what should organizations actually be looking for?
This is a good example of why is it publicly accessible is not the same question as should it be publicly accessible. From a defensive standpoint, the first question I would ask is, if I don't authenticate to this application, what can I actually see? Not what the documentation says I should see, not what the guest account can see. Actually create an unauthenticated session and find out. For MSPs, this is especially important because you're often managing environments that you didn't design. A customer may have a Salesforce portal or a ServiceNow instance that has been accumulating configuration changes for years. I'd specifically look at guest permissions, public sharing rules, object and field access, file access, obviously, search sources, and even self-registration. And then there's also the detection side of things. An attacker quietly enumerating public data may never generate the kind of alert we'd associate with a traditional intrusion. You may instead see repetitive API requests, unusual search behavior, and a sudden increase in data retrieval from an anonymous source. The takeaway here is not turn off public access, because sometimes public access is the product. It's exactly what we need, right? The takeaway is to know exactly what public access provides.
Thanks, Matt. Our next story comes with an important caveat. A threat actor known as the Hat Man has been claiming to have stolen large amounts of employee organizational data from Azure and Entra environments belonging to major companies. The claims have included organizations such as McDonald's, Vodafone, Kyndryl, and others, with the threat actor claiming millions of records in total. But we need to separate what's being claimed from what has been independently confirmed. Some samples of the alleged data have reportedly appeared online, and researchers are investigating whether portions of the data are legitimate. At the same time, some of the organizations named in the claims have disputed that their environments were breached. So we're not going to call this an Azure breach. The more interesting part of the story is how the access is believed to have occurred. The reporting points toward compromised credentials and sessions rather than somebody finding a vulnerability in Azure itself, and that distinction matters. Why? Because if an attacker logs into your cloud environment using a legitimate credential, the first event in your logs may look exactly like a legitimate login. If the attacker is using a legitimate credential, how do you tell the difference between a normal user and someone who shouldn't be there?
This is where identity security gets uncomfortable. We tend to think of authentication as a security boundary. Did the person successfully log in? Yeah, great. But that's only the beginning. If someone steals a valid credential or a session token, the authentication may do exactly what it was designed to do: let them in. The defensive question becomes, what does that user do after they authenticate? Are they suddenly accessing resources that they've never touched before? Are they enumerating users or groups? Are they downloading unusually large amounts of data? Are they authenticating from an unexpected device or location? Yeah, there's a pattern here. Are they creating tokens, applications, permissions, or other mechanisms that you allow them to come back later? Establish persistence? This is why MFA shouldn't be treated as the end of a conversation. While MFA is extremely valuable, but depending on what was stolen, an attacker may be operating with a session that's already past authentication. So the lesson here is not that MFA doesn't work. It absolutely does. It's that authentication and authorization are not the same thing. And, at the end of the day, neither tells you what the user actually did.
When we talk about AI security, we tend to talk about the AI itself, the model, the prompts, and the data. But there is another layer that's becoming increasingly important: the infrastructure that makes AI work. CISA recently added a critical vulnerability in Ray, an open-source distributed computing framework used for AI and machine learning workloads, to its known exploited vulnerabilities catalog. The vulnerability CVE-2025-62593 can allow remote code execution, and the attack path is particularly interesting. A vulnerable Ray deployment exposes HTTP API endpoints without sufficient authentication. Under the right conditions, an attacker can use a DNS rebinding technique to get a victim's browser to interact with the Ray service and ultimately execute code. This means an AI developer can potentially be compromised not because their AI model was attacked, but because of the infrastructure they installed to run that AI workload. If an organization is adopting AI, what should they be looking at beyond the AI model itself?
This is one of those stories where the technology name is way less important than the lesson. Organizations are rapidly adopting AI, but adopting AI often means deploying a whole collection of supporting infrastructure. We've got frameworks, inference servers like the little guy got down here, vector databases, agent runtimes, developer tools, container environments, and every one of those things becomes part of the organization's overall attack surface. This is not unique to AI. We've been doing this with every new technology for decades. The difference here is that AI adoption can happen extremely quickly, sometimes outside of that normal infrastructure and procurement security review process. So if your organization is using AI internally, I wouldn't just ask, which AI services are we using? I'd ask, what did we deploy to make them work? Where is it listening? Who can reach it? Does it have authentication? What permissions does it have once someone's authenticated? And also, what does anyone actually know? Does anyone actually know that it exists? There's a lot of moving parts behind the scenes that you don't always see. CISA's Kev listing also gives us the operational piece. This isn't just an interesting theoretical vulnerability. There's actual evidence of exploitation. So if Ray exists somewhere in your environment, this is a good example of why discovery matters before vulnerability management can even begin.
Our final story is about AI, but this time the AI itself is the actor. During a cybersecurity evaluation, OpenAI agents escaped their intended testing environment and ultimately compromised Hugging Face infrastructure. The important part isn't simply that an AI was able to hack something, or that this is some kind of marketing scheme. These systems are being evaluated specifically for cybersecurity capabilities, so they were given tools and enough freedom to perform meaningful security work. The problem was that the testing environment didn't remain as isolated as intended. The agents were able to get outside the boundaries of the evaluation and interact with the real external infrastructure. And now, OpenAI is changing how it performs some of these tests. The company has paused certain reinforcement learning work, strengthened sandbox isolation, restricted internet access for high-risk workloads, and is adding automated monitoring designed to identify dangerous activity within 30 minutes. OpenAI has also acknowledged uncertainty about whether its existing monitoring techniques are sufficient. So the story isn't really AI went rogue. It's much more familiar than that. A system was given privileges, the security boundary wasn't strong enough, and the system used those privileges in an unintended way. If an autonomous agent can operate on its own, how do we make sure its capabilities don't extend beyond the boundaries we've given it?
This is where I'd bring the conversation back to security fundamentals. If I gave a human security researcher access to a system and told them, go find vulnerabilities, I wouldn't be surprised if they found vulnerabilities. I would, however, be surprised if I didn't carefully control where they were allowed to go. An autonomous agent needs the same thinking and arguably more of it. What can it access? What credentials does it have? Can it reach the internet? Can it access internal networks? Can it create new credentials? Can it modify its own environment? And, well, can it communicate with other agents? And critically, what happens when it encounters something it wasn't supposed to encounter? This is where least privilege, segmentation, egress controls, monitoring, and rapid containment still matter very much. AI doesn't invalidate those security principles. It makes them more important because, look, a human attacker has to make decisions one at a time, right? This thing doesn't work that great. One at a time, single-threaded. An autonomous agent, though, can potentially make thousands of decisions while we're still trying to understand what the first 100 meant. OpenAI's response is telling. They're not solving this by simply saying, make the model behave, because we know that doesn't really work, right? They're also strengthening the environment around the model itself, and that's the right security instinct to have. Don't rely on the actor to behave. Control what the actor is capable of doing.
And that's it for this week's Blumira Briefings. The common thread across these stories wasn't necessarily a new vulnerability or a new attack technique, it was trust. What we've exposed, what we've authorized, what we've deployed, and what we've allowed to act on our behalf. The lesson isn't that we should stop using these technologies. It's that we need to understand where the boundaries actually are and what happens when something crosses them. We'll be back next week with more.